Function composition is simply plugging one function into another. For example, you might see f of g of x. The way you say that is f of g of x. That's how you say it. What does it mean? It means that the function g of x is being plugged inside the function f of x. So for example, let's say f of x was equal to 2x plus 1. And let's say g of x was equal to x squared minus 2. I could ask you what f of g of x is. That's simply going to be 2, and instead of x, you are going to write g of x. So you're replacing the x with g of x. Now what does g of x equal? It equals x squared minus 2. So you end up with f of g of x is equal to 2 times x squared minus 2 plus 1. You could simplify it a little bit and say that it's equal to 2x squared minus 4 plus 1. So it would be equal to 2x squared minus 3. So your final answer for g of f of x, f of g of x rather, sorry, f of g of x is 2x minus 3. You could even have numbers in there. So for example, let's say I gave you j of x equals x squared plus 2 and p of x is equal to 3x minus 1. I could ask you, what is j of p of 2? In order to do that, you do it from the inside out. You first find out what is p of 2. In that case, it's going to be p of 2, 3 times 2 minus 1. I took p of x and I just plugged in 2 for x. So this is going to equal 6 minus 1 is 5. So we now know that this is equal to 5. So now we're evaluating j of 5. J of 5 is going to be x squared plus 2, but instead of x we're putting a 5 in. So that's going to equal 25 plus 2 is 27. So just remember, function composition is simply plugging one function into another function. One thing that's important to realize is that the order of the composition matters a great deal. So let's say I asked you what p of j of 2. It's similar to this, but instead of doing j of p of 2, we're doing p of j of 2. So in this case, I'm first going to have to figure out what is j of 2. Well, j of x is x squared plus 2, so that's going to be x squared plus 2, so 2 squared plus 2, that's equal to 4 plus 2, so that's equal to 6. And now you take this 6, and you know that that 6 is going to go right there. So now we need to do p of 6. Remember, p of x is 3x minus 1, so 3x minus 1, you plug in 6, you end up with 18 minus 1 is 17. So what this shows is that the order in which you compose a function matters a great deal. Another thing to realize is that you can compose a function with itself. So for example, let's say n of x was equal to 3x plus 1 squared plus 2. It's a little bit more complicated, but we can handle it. Let's say I asked you what n of x is. What does that mean? It means plug n of x inside n of x. So instead, I'm going to write a blank for the x. So this is where x was going to go, right here. But instead of x, I'm writing n of x. So what is this thing going to look like? Well, it's going to be pretty large, but you can still write it out. So it's going to be 3 times, and instead of n of x, we're going to write what n of x is. It's equal to 3 times x plus 1 squared plus 2 plus 1 plus 2. So keep in mind, all of this is the same. This 3 is right there, this squared is right there, that 2 is right there, that 1 is right there. The only thing that's changed here is now you have this, which is n of x. So yes, this thing is really big. It's a complicated example, but it's important to realize you can plug a function into itself. So to review, if you see this written out, it means f of g of x, which means you're plugging the function g of x into f. So you're literally taking g of x and plugging it inside f wherever x is written. And you can come up with a function because I didn't give a value for x, or I could ask you, I could put a number in and ask you what it numerically evaluates to. You plug in the number to the inside function first and work your way outwards. It's also important to realize that the order matters a great deal. If you did, in this example, we did j of p of 2 and it came out to be 27, but then we did p of j of 2 and it came out to be 17. So j of p of 2 is one answer, p of j of 2 is another. The order matters. Last, I pointed out that you can put a function into itself. This one was a complicated example, but nothing really changes except it's just fill in the blanks.